Hi guys, today we're going to talk about factoring. Factoring is something that's really important to understand, and it's considered to be the fifth operation in algebra. There's no symbol that tells you to factor, but if the directions say factor, then you'll know that that's what you're supposed to do. If you don't learn how to factor, you're going to have a really hard time in college algebra or any more advanced math classes that you take. And there are 5 different rules of factoring. Today we're going to talk about factoring by GCF and the grouping method. GCF stands for greatest common factor, and that is the largest divisor or factor that both numbers have in common. What I mean by divisor is it's a number that can divide into that number. So if we look at this first example, what is the GCF of 6 and 8? So the biggest number that will divide into both 6 and 8, what would that be? 2. 2 is the greatest common factor of 6 and 8. What about between 15 and 50? That would be 5. All right, what about between 3 and 7? Well, 3 and 7 are both prime numbers. So they don't have any divisors besides 1 in themselves. So the greatest common factor of 3 and 7 would be 1. What is the greatest common factor of 5x and 3x? Well, 5 and 3 are also prime numbers, so they don't have any common factors besides 1, but they have something else in common. These two terms have something else in common. What do they have in common? They both have an x. So x would be considered the greatest common factor of 5 and 3. Now in number 5, we have two terms with several parts in them. 8ABC and 12AC. So let's break it up. If we look at the number part of our terms, 8 and 12, what is the greatest common factor? Well, 2 is a factor of 8 and 12, but it's not the greatest common factor. What is the biggest number that can divide into both of those terms? 4. 4 will go into 8 2 times and 12 3 times. Okay, let's see what else they have in common. Both terms have an A. Only this term has a B, so B is not something that they have in common. And then they both have a C. So 4AC would be the greatest common factor of these two terms. All right, the greatest common factor of 14x to the 5th y and 21x squared y to the 3rd, let's break this up again. If we look at the number part, what's the greatest common factor between 14 and 21? That would be 7. And we see that they both have x's and they both have y's, right? So we're going to include those, but we need to know how many they have in common. So if I write this out, let's look at it this way. In this first term, we have 1, 2, 3, 4, 5 x's, and in this one we only have 2. Okay, so then how many do they have in common? Well, we can say that this one has 2 and this one has 2. They don't both have 5 in common because this one only has 2. So x squared would be what they have in common. Okay, and then for the y's, this has 1y and this has 3 y's. So how many y's do they have in common? They only have 1 y in common. So we don't have to put an exponent on the y. It's understood to be a 1 there, so we can just leave it. And so my greatest common factor between these two terms is 7x squared y. So another way to determine that is just when we're dealing with variables, it's always going to be the variable with the smallest exponent. So when we looked at these two, the smallest exponent for the x's was 2. For the y's, the smallest exponent was the understood 1. Okay, now what we were just doing, we weren't factoring. We were just finding the greatest common factor. Now we're going to factor by finding the greatest common factor. Now anytime we factor, our answer is, we could always take our answer and multiply it back together and get what we started with. So in this first term, we start by finding what the greatest common factor is. So if we look at these two terms, this 6x and 6y, what do they have in common? They both have a 6 in common. Now, we take what we write what we factored out, and then we divide both of these terms by whatever we factored out, and we write what we have left, x minus y. Now, the way that you can check your answer anytime you factor, like I said, you should be able to take your answer and multiply it back together and get what you started with. So this is my answer, but let's check my answer. Okay, to check my answer, I would distribute or multiply these two factors back together. And if I distribute that, I would get 6x minus 6y. And that's what I started with. So that's the way to check. Okay? And if you can't get what you started with by multiplying them back together, then you didn't do it right. Okay, so for number 8, what do these two terms have in common? Well, we see that they both have y's. How many y's do they have in common? Just one. We always use the smallest exponent. Okay, so and you don't have to write this part out. This is just a visual way of seeing what we're really doing. So if I divide both of these parts by whatever I factored out, remember when we divide variables, we subtract the exponents. So if I take away 1 from 3, then I have 2, okay? So that would be y squared. And then here there's 1y and 1y, so they just cancel out, minus 8. Okay, so again, if I check it, y times y squared, that would be y to the 3rd. Y times y to the 8th, that would be, or negative 8. I said y times y to the 8th. Y times negative 8 would be negative 8y. All right, and that's what I started with. So that's how I know that my answer is correct. Okay, in number 9, what is the greatest common factor? Okay, in the number part, 7 and 21, what do they have in common? Well, 7 is a prime number, which means that it can be divided by 1 or 7. Now, can 21 be divided by 7? Yes, so both of these can be divided by 7. So 7 is the greatest common factor between the numbers. They both have x's, and we want to use the smallest exponent. All right, so it would be x squared. Now, if I divide this by 7x squared, I would get x squared. If I divide this by 7x squared, then I would get a negative 3. Okay, so then just in your head, you can check that. 7x squared times x squared would be 7x to the 4th. 7x squared times negative 3 would be negative 21x squared. All right, what do these two terms have in common? Well, I see they both have a pi, and then they both have r's. Well, this one only has one r, so that's going to have to be our greatest common factor. If I divide this by pi r, then I'm left with just one r. If I divide this by pi r, I'm left with minus 2h. Okay, again, pi r times r would be pi r squared. pi r times negative 2h would be negative 2 pi r h. Okay, in number 11, what do they have in common? 4 would be the greatest common factor. All right, so if I divide 16x by 4, I get 4x. Now this is a common mistake that students make. Well, let me go ahead and write it out like I've been doing. Okay, so if I divide this by 4, divide this by 4. So 16x divided by 4 is 4x. Now, what a lot of students end up doing is they take this and they just cross it out. Okay, well, when we're dividing, 4 divided by 4 is not 0. What is 4 divided by 4? 1. So this would be minus 1. Now, if you did what I did at first and just marked it out, then I would have 4 times 4x, and that would be it, right? Because if I just canceled that part out. But then if I multiply it back together, 4 times 4x would just be 16. And that's not what I started with. I started with 16x minus 4. So that is not correct. But if I check this, I get 16x, and then 4 times negative 1 would be minus 4. All right, so that's my answer. Okay, in number 12, we have 3 terms, and we can do GCF with 3 terms, 4 terms, however many terms. We're just looking to see what all of the terms have in common. Okay, so if we look at the numbers, what is the biggest number that can divide into all 3 of these numbers? It would be 2. Okay, and then there's an x to the third, x squared, and an x. So x, just an x. Then we have y, y, and y. All right, so a y. Now, if I divide this by 2xy, that leaves me with x squared. If I divide this by 2xy, that would leave me with minus 2. And if I divide this by 2xy, I would get plus 9. Oh, I didn't write my x here. That should be 2x. Okay. And this is my answer. And so if I had just written a 2 there, when I multiplied these 2 terms together, I would just get 4xy, and it should have been 4x squared y. So that's why you should always check your answers. And like I said, you don't have to write it out, but just mentally, just check. Okay, if I multiply this together, make sure with each term you get what you started with. All right, in number 13, so I have, for my number part, I have 4, 3, and negative 1. Okay, so the biggest thing they have in common as far as numbers go would just be 1. But let's not write that yet, because if I have a variable, I don't have to write the 1. Okay, so then let's look at A's. Do they all have A's? Yeah, they all have an A. Do they all have B's? Nope, this term doesn't have a B. Do they all have C's? Nope, this one doesn't have a C. So A is the only thing they have in common. So if I divide each term by A, I would get 4AB plus 3C minus BC. And that's my answer. All right, factoring by grouping. So this method is used when you have 4 monomials, or a polynomial with 4 terms, and all 4 terms have no greatest common factor. We use parentheses to group the monomials 2 by 2, and then we factor the greatest common factor out of each group. Your answer should always be 2 binomials. So if I look at number 14, I see that they don't have anything, all 3 terms don't have anything in common. They don't all have a B. This is a 1, so the same number can't go into all 3 terms. So we're going to factor by grouping. And what we do is we group the first two terms, leave the sign in the middle, and group the last two terms. Now we look for a greatest common factor in each group. So in this first group, what's the greatest common factor? B squared. So if I factor out a b squared, I'm left with b plus 3. I bring down my sign. What's the greatest common factor in these two groups? 4. Okay, so if I divide each of these terms by 4, I'm left with b plus 3. Now, when we get to this step, the things that we have in our parentheses should look the same, and they do. So it's like this is a term. Remember, a term is something like 3x. Okay, so this is like 3x. This is a term. It's two things being multiplied together. Okay, so in these two terms, in this first term and this second term, what do they have in common? What is their common factor? The b plus 3's. So I'm going to factor that out. Factor out b plus 3. Okay, so once I divide by b plus 3, divide each term by b plus 3, what's left? B squared plus 4. And that's my answer. Like I said, the answer will always be two binomials. So here is my answer. Now, if you write it like this, b squared plus 4 times b plus 3, that's okay too. It doesn't matter which order your groups are in, as long as the things inside the parentheses are the same. Like you couldn't have b squared plus 3 is b plus 3 and b squared plus 4. But you can switch the order of the groups. So either one of these. All right, so number 15, did they have something in common? All 4 of them. No, so let's group the first two, leave the sign in the middle, group the last two. Okay, so what's the greatest common factor here? Well, I see they can both be divided by 2, and the smallest exponent in the x's is x squared. So if I divide this by x squared, I'm left with x, or 2x squared. And if I divide this by 2x squared, I'm left with just 7. Plus, what do these have in common? A 3. Okay, so if I divide both of these by 3, I'm left with x minus 7. Okay, so again, now that I'm at this step, these two things in parentheses should be the same. And if they're not, you did something wrong. Okay, so I take these two things in parentheses and factor that out. So I'm factoring out x minus 7. And when I take that out, I write what I have left, which is 2x squared plus 3. And that's my answer. Okay, number 16. Do they all have something in common? No. So I'm putting parentheses around these two, leave my sign in the middle, and the last two. Okay, now what do these have in common? An x. Okay, so if I divide each term by x, I'm left with, so if I divide this by x, I'm left with y. If I divide x by x, what is that? 1. So plus 1. They don't cancel out, remember? Plus, what do these have in common? Okay, so anytime we're factoring by grouping, if there, if there is nothing else that they have in common, they can both be divided by 1. So we have to pull out a 1. We have to pull out something. So if there's nothing else that they have in common, pull out a 1. And that would work because if I multiply these both by 1, I still get what I started with. Okay, so if you'll notice, the stuff in the parentheses are the same, so I factor that out and write what I have left, which is x plus 1. Okay, in number 17, again, we don't have anything in common. So we're going to go ahead and put parentheses around the first two. Now this one is different than number 16 because the sign in the middle is negative. Now this is something you have to be very careful about. Anytime we're doing grouping and the sign in the middle is negative, when we put up the parentheses, it's kind of like we're going backwards from distributing. And we have to, so this was a negative y. Once I put up the parentheses, it changed that y to a positive y inside the parentheses. So we also have to change this sign, whatever that sign is, it's negative, so we're going to change it to a positive. If it were positive, we would change it to a negative. So we're changing it to a plus, and so we always check it to make sure, if we were to go backwards and we were to distribute that negative, that would become a negative y and a negative 1, which would have been what we started with, okay? So anytime that middle sign when we're doing grouping is negative, make sure you change this sign. Okay, so because that's negative, we change that sign. All right, so now we're going to continue on just like we've been doing. When we look at these two groups, what do they have in common? An x. So if I factor out an x, I'm left with y plus x divided by x is 1. Bring down that sign, that's minus. What do these have in common? Nothing except for 1. And bring that down, y plus 1. Now, if you had forgotten to change this sign, this would be where you would catch it. Because remember, these two things need to look the same. And if you didn't change this sign, you would have y plus 1 and y minus 1. And that wouldn't be right. Okay, so now that they are the same, we factor that out. And we write what we have left, which is x minus 1. And that's how we factor by grouping.